All right, guys. For today, we are looking at factoring a difference of squares. So just a new way to factor. This is my favorite way to factor. So you will hear me all semester long be like, those are my favorite. And I always have students as the semester goes on, they're like, I don't know how to factor this. And I'm like, it's my favorite. And they're like, oh yeah. And then they're like, okay, I remember how to factor it now. Okay, but this is my favorite, honestly, because they're the easiest. They're the easiest ones to factor. But I will tell you right now, more students miss these than anything else. I think that they just overthink them. All right, so this is the type we're factoring today. 16x squared minus 25. Why is that different from what we've been factoring? It's what? It's only two numbers. Everything we've been factoring has had three. Right? It's always been an ax squared, the bx, and then the c. So could I potentially rewrite this to give myself a bx in the middle? What would the bx term be? Do you see 1x? Somebody said it over there. 0? 0x? Did I change anything? I didn't change anything, right? If I add 0 to something, it doesn't change it. But now it has three terms. Okay? So let's go ahead and factor it. So there is no GCF. So I'll set up my parentheses. Last one's negative. So how do you multiply to get a negative? Good. Options for A, 1 and 16, 2 and 8, 4 and 4. Options for C, 1 and 25, 5 and 5. You want to go 1 and 16, 2 and 8, 4 and 4. Four and 4 and 5 and 5, just because it sounds fun, right? 4x, 4x. And then we'll go 5 and 5. Because remember, we're trying to get a 0, right? So when I check these, that gives me 20x. That gives me negative 20x. 20 minus 20 is 0x. So that is factored. So is it really much different from what we've been doing? No. But why are these my favorite? I didn't tell you the other ones are my favorite. These ones are. Look at the types of numbers that you have. What do you notice about 16 and 25? They're what? They're perfect squares. What numbers did I use in my factoring? What's the square root of 16? It's the square root of 25. What numbers did I use? 4 and 5. I used their square roots. You like that? Those are the fun ones because they're going to be perfect squares. So then I can just use their square roots to put in here. What do you know about the signs? If that last one's negative, one's plus, one's minus, do they have to be 1 plus, 1 minus in order to make a 0 in the middle? Yeah. So they're going to have a minus sign there. That way that makes the last one negative, which gives me 1 plus, 1 minus, so that they can cancel out and give me nothing in the middle. Okay? So looking at your flow chart, right, we were all in the 3-term stuff over there. We can shift over to 2 terms. With 2 terms, they are going to be, it's called a difference of squares because difference means subtraction, and they both need to be perfect squares. Okay, so perfect squares with a minus sign. Since that last one has to be a minus sign, it's always going to be plus minus. And I'm just using the square root of each number to plug those into the parentheses. So is there much guessing and checking going on? No, there's none, which is why I like them. Remember, I'm a lazy mathematician. That's less work for me. Okay, again, reminder of your signs. Last one has to be negative, so one's going to be plus, one's going to be minus. So there's your book definition. Book definitions sometimes are overrated. All right, so looking down here, we have which of these expressions can be factored using the difference of 2 squares. So which one of them kind of fit the mold? That they have 2 terms. They have to have what kind of sign? A negative sign. And what do I know about the numbers? What do they have to be? They have to be perfect squares. So what about the first one? X squared minus 25. Does that one fit the requirement? Do I have 2 terms? A minus sign? Are they both perfect squares? What's the square root of x squared? It's just x. Right, there's a 1 in front of it. Square root of 1 is 1. So does that one work? Yeah. How would it factor? Last one's negative, so your signs are opposite. One's plus, one's minus. What's the square root of x squared? X. So 1x and 1x. Square root of 25? It's 5. 5 and 5. Right? I'd want that middle bx term is nothing, right? I would need it to cancel. You'd get 5x minus 5x. They would cancel. That's factored. What about 12x squared minus 4? Why not? 12 is not a perfect square, but is there a GCF sitting there? What's a GCF? 4. Let's take out a 4. If I take out a 4, what do we have left? 3x squared minus 1. So I could factor it technically, right? I could take a GCF out. But is that a difference of squares? Two terms, minus sign. Are they perfect square numbers? Which one's not? I don't have a 12. 3. 3 is not. Okay. Sometimes the original problem, they're not perfect squares, but if you take the GCF out, then they are. So you got to be careful and look for that. But yeah, since this 3 is here, that's not a perfect square. That does not factor any further. I would be done. All right, 9x squared plus 16. Why not? There's a plus. Yeah, in order to get that middle term to cancel, I need 1 plus 1 minus, so they cancel it to 0. The last one's positive. My signs would not be plus minus. So that one I can't do anything with. 36x squared minus 1? Yeah. Right, I have two terms. I got the minus. 36 is a perfect square. 1 is a perfect square. How does it factor? If my last one's negative, my signs are positive, negative. Square root of 36x squared. So that's 6 and 6 is what I'm going to use. And square root of 1. So 1 and 1. Now, for whatever reason, I see it all the time. Students, I'm like factoring these, because these should be the easiest factoring you do all year, okay? But for whatever reason, they're the most missed. Students, I'm like, all right, factor it, and they'll write 6x plus 1. And that's it. How do you turn a 6x plus 1 back into the original problem? You can't, right? We have to keep in mind when we're doing these, I should be able to check this and get back to where I started. So that way, hopefully, you're not going to forget some pieces to these. All right, so how about x squared minus 49? How does that factor? Is there a GCF? No GCF. Is it a difference of squares, though? Two terms? Minus sign? Perfect squares? Yeah, so how's the factor? Good. X plus 7, x minus 7. Can I still check these to make sure they work? Yeah. If you still check, you're going to get 7x. That's going to give you minus 7x, which is going to give you 0x, which I don't have any x's. So I can still see it works. All right, how about the next one? 16x squared minus 1. GCF? No? Two terms? Minus sign? Perfect squares? All right, I'm good. But in your mind, that's like the checklist, right? Those three things. Perfect squares, minus sign, two terms. All right, so how does it factor? Good. 4x plus 1, 4x minus 1. Are you starting to see why these are my favorite? They're so fast. 25x squared minus 36. GCF? No GCF. Two terms? Minus sign? Perfect squares? All right, let's do it. How does it factor? Good. 5x plus 6, 5x minus 6. Done. Yay! You got a whole page of these, right? It's kind of fun. At least I think they are. You may not. 50x squared minus 18. GCF? What can I take out? A 2. If I take out a 2, what am I left with? 25, don't forget your x squared, minus 9. All right, can I factor further? Do you have two terms? Minus sign? Are they perfect squares? Are you annoyed with me asking these questions yet? Yeah, it's okay, you can say yeah. How does that factor? don't lose baby brother, right? He's still hanging out up front. Now, look back at the original problem. If you had forgotten to look for the GCF, could you have factored it? No, because 50 and 18 are not perfect squares. So you have to make sure you're looking for that GCF first. 64x squared minus 100. What are you going to do with that one? Thank you. How many of you already started factoring that? Anybody go 8x plus 10 and 8x minus 10? Wrong. What's the first thing you look for? GCF. What goes into both of those? 4 goes into both of those. If I divide them both by 4, what do we get? 16x squared minus 25. Now can I factor further? 2 terms, minus sign, perfect squares, checks all the boxes there. All right, so how does that factor now? 4x plus 5, 4x minus 5. Now, for those of you that were like, yeah, I factored it right from the start, and I'm like, wrong. You're like, oh, let's take a look at it. So right away, they are perfect squares. You're like, yeah, 8x plus 10, 8x minus 10. Look at your parentheses. Is there a common factor in both of those? Yeah. There's a 2 in here and a 2 in here, and 2 times 2 makes the 4 that you should have taken out from the beginning. Okay, so if you went ahead and factored here, I need you to recognize you have a GCF sitting in there. Okay, that should be that little check you do every single problem. Look at your parentheses. Is there something common? If there is, stop yourself, take it out. Or go back to the beginning and take it out from the start. Either way. Okay, but that is wrong because that's not fully factored. 12x squared minus 75. What's the first thing you look for? GCF, is there one? 3? Okay, we'll take out a 3. What do we have left when we take out a 3? Minus what? 25, there you go. All right, taking out the 3. After I take out the 3, 2 terms? 3, talk to me. Do I have 2 terms? Do I have a minus sign? Are they both perfect squares? Let's factor it. How's a factor? 2x squared? Good. 2x plus 5, 2x minus 5. Don't put squareds on there, because if you put a squared on both, x squared times x squared is x to the 4th. You've created something different than what you started with. Okay? All right, so why don't you guys go ahead and try these 3. All right, first one, 121x squared minus 144. Is there a GCF? Yeah, there's nothing that goes into both. Are they, do I have 2 terms? Minus sign? Are they both perfect squares? All right, so I can factor it. How's the factor? Good. 11x plus 12, 11x minus 12. Good. All right, x squared plus 100. GCF? Nope. Do I have 2 terms? Are they both perfect squares? Yeah. Do I have a minus sign? No. Can I factor that? No, I cannot factor that. That does not factor because there is a plus sign right there. So I saw numerous people do x plus 10, x minus 10, which if that was a minus sign, that'd be perfect. But it doesn't actually work. Now, I did see someone give me this, x plus 10 squared. So somebody do that. What does that mean? It means there's 2 of those. So would that work? X plus 10 and x plus 10? What's going to happen to that inside? 10x and 10x make 20x. I don't have a 20x. That does not work. Okay? So I try to be as obnoxious and annoying as possible to keep repeating the same thing over and over and over again, so hopefully it sticks in your head so you remember that. Okay, you got to kind of go through those 3 checkpoints. All right, 4x squared minus 75. Is there a GCF? Nope. 2 terms? Yeah, I got 2 terms. Do I have a minus sign? Are they perfect squares? What's not a perfect square? Yep, the 4 is good, the x squared is good, the minus is good. I got 2 terms, but that stinking 75 is not a perfect square. This is unfactorable. So homework tonight, you're going to see some of those kind of thrown in there. So you have to watch. Don't just assume everything on the page you can factor. I need you to start thinking about the process of it, okay? 4x squared minus 25y squared. Wait a minute. There's 2 variables on there. Can I do 2 variables? Yeah, I can. Do I have 2 terms? Minus sign? Are they both perfect squares? Yeah. Okay, so how's that factor? Yeah. Very good. Because we're always just doing the square root, right? The square root of 4x squared is 2x. The square root of 25y squared is 5y. Just got an extra variable stuck to it. Because then people are like, wait a minute, what happens when you put them together? So if you check that, that's going to give you a negative 10xy. Outside would give me a positive 10xy. So they're still going to cancel out and give me 0xy, which means there's no term in the middle. So it still works. Okay? So extra variable, don't panic on that. What about the next one? Beautiful, isn't it? What would you do with that? What's the first thing? Yeah, GCF. What is the GCF? 2z. All right, so if I take out a 2z, all right, taking 2z from both of these, what are we left with? Good. So this is why it has to be in the forefront of your brain. Every problem you do, is there a GCF? You've got to look for that first. So looking for that, I pulled out the 2z. What do you have left? Do you have 2 terms? Do I have a minus sign? Are they both perfect squares? Yeah, which means I can factor it. How does it factor? Good. That's why these are my favorites, because they're easy. They should be easy as long as you remember GCF first, and then your 3 things to check for. 2 terms, minus sign, perfect squares. Now, I do have one more problem for you to add to your notes. Add that one to your notes for me. Just because I know it comes up all the time. People get themselves confused. Right away, people look at that, they notice a couple things. They're like, there's a plus sign in the middle, and they're not perfect squares. I could take out the what? And 2. Take out a negative 2. Remember, we just talked that homework problem. If that first one's negative, you have to take that out. And 2 does go into both of them. So if you take out a negative 2, what are you left with? Good. I'm left with x squared minus 36. Is that still 2 terms? Is there a minus sign? Are they perfect squares? People are very rude. All right. So from the very beginning, it looked like it did not meet like hardly any of my criteria. But once I take out that GCF, now I can factor that. How's it factor? Good. So anybody want a whole page of these on the test? Right? I like these. A lot faster. But I'm going to tell you right now, for whatever reason, people struggle with these more than anything else. Today, you'll be great at them. Next week, when I'm like, all right, let's go ahead and factor, and I give you a page of like all the types of factoring, you're going to be like, I don't know how to factor that. I know it's going to happen. Let this be the year it doesn't happen, okay, guys? Can you do that for me? Because it drives me crazy because they're the easy ones.